Section 4.4 is on finding the trigonometric functions of any angle. If we look at part 1, it says the definitions of trigonometric functions of any angle. Let theta be an angle in standard position, and let P equal the point xy, the ordered pair xy, be a point on the terminal side of theta. If r is equal to the square root of x squared plus y squared, is the distance from the origin to your point P, as shown below, and we have 4 cases on the handout that we're going to talk about, then our 6 trig functions of theta are defined by the following ratios. Okay, this is what I was talking about earlier when I said we're going to have different ways to define the trig functions. Okay, it's actually the same meaning. For example, let's go ahead and look at the first diagram that we have. If I'm looking at this angle theta, we can tell by our right triangle definitions for sine. Remember, sine would be opposite over hypotenuse. Well, in this case, it's just that my opposite side is y, my hypotenuse is r. And then on the unit circle, we said that sine was equal to y. That's because our r value on the unit circle was a 1. So for the problems we have here, your r value could be another number, not just 1. So for the purposes of our definition, we say the sine of theta here would equal y over r. The cosine of theta, remember, adjacent over hypotenuse, so that would be x over r. And tangent of theta, opposite over adjacent, would be y over x. Okay, and then we have our reciprocal functions. Cosecant would equal r over y. Secant of theta would equal r over x. And cotangent of theta would be x over y. Okay, if we look again at our diagrams here, notice that these definitions extend to angles that are not just acute angles. Here I have an angle that's in quadrant 1, where the terminal side is in quadrant 1. Here I have where theta is in quadrant 2, my terminal side is in quadrant 2, but we're still kind of referencing this right triangle to find our trig values for this angle theta. Okay, here we have where theta is in quadrant C, and then here where theta is in quadrant 4. So we can expand and look at angles that are not just acute angles. So let's look at the first example. It says let P equal the ordered pair -3, -5. That's a point on the terminal side of theta. We want to find the 6 trig functions. Okay, so if we draw a diagram, we know that -3, -5 would be in the 3rd quadrant. And I'm just going to kind of estimate that here. This is point P. So actually the angle that I'm referring to is here. Okay, remember we said in standard position, that's from the positive x-axis around to my terminal side. Okay, so I know that the distance here is 3, and here, if I had a right triangle, would be 5. All I would need in order to find my 6 trig functions would be the length of this hypotenuse for this right triangle, which would be my value for r that we referred to up here earlier. So if I wanted to find the value of r, or that hypotenuse, I could use the Pythagorean theorem, which says r equals the square root of x squared plus y squared. So r would equal the square root of 3 squared plus 5 squared. So r is the square root of 34. We're just going to keep it as a radical. That's not going to reduce. And again, just for notation, remember x is equal to -3 and y is equal to -5. Okay? But it still made it positive here when I squared it. So now to find my values, the sine of theta would equal y over r, so that would be negative 5 over the square root of 34. And so remember, we have to rationalize. So if I rationalize my denominator, we would have negative 5 square roots of 34 over 34. That's the sign. If we want to go ahead and do the reciprocal, we could do that. So cosecant of theta would be the square root of 34 over negative 5. The cosine of theta would be x over r. So x is negative 3. R is the square root of 34. Again, you'd have to rationalize. So that gives us negative 3 square roots of 34 over 34. The reciprocal, or the secant of theta, would be square root of 34 over negative 3. And then the tangent of theta would be y over x, so negative 5 over negative 3, which would just be 5/3. And then the cotangent of theta would be 3/5, would be the reciprocal.